Hello, everyone. Mr. Minnick's my name. Math is my game. And today, I'm pretty excited. This is a moment we've all been waiting for. Chapter 4, Section 4. Officially, we're now going to look at factoring. And in this section in Chapter 4, basically, there's going to be a lot of language I'm going to throw around that I want you to understand. And honestly, this is kind of setting up Chapter 5. So I want to talk about what it means for something to be quadratic. Anytime I mention the word quadratic, if you think from a visual perspective, it implies or insinuates that we're going to be dealing with something that looks like a parabola. Whether it opens up or whether it opens down, anytime the word quadratic is mentioned, graphically speaking, we're going to be looking at a parabola. Algebraically speaking, what we're going to see is some variable x, and what's most important about it that you need to realize is what its power is going to be, what its exponent's going to be. Anybody have any idea what that's going to be? 2. Okay. So when we mention quadratic, realize we're talking about something with a variable x in it and an exponent of 2, and no higher exponent than 2. Okay. So to build on this idea, we could talk about a quadratic trinomial. We could talk about a quadratic trinomial. Now, if you look at the root word in trinomial, or the prefix, I should say, not the root word, but the prefix. What's the prefix in trinomial? Tri. And what's tri mean? 3. And when we talk about omials, we're talking about things that have several terms, right? So how many terms do you think a quadratic trinomial has? 3. Might have something like 16x minus 4x squared plus 1. That particular quadratic trinomial is not written in the order we like it, but it does have 3 terms. Its biggest exponent is 2, and it is a quadratic trinomial. Make sense so far? Cool. The way that should be written, it should be written as negative 4x squared plus 16x plus 1. That's called standard form, and we'll talk about that when we get to Chapter 5. But I am going to be using this language, this terminology, and I expect you to understand the terminology that I'm talking about. So the one thing I never understood about putting Chapter 5 after Chapter 4, we use all this language that shows up in Chapter 5 in Chapter 4. So along the lines of quadratic is something called linear. And this is basically what we skipped over mostly in Chapter 2 because you did a lot of this in geometry. You did a ton of this in Algebra 1. So when you think about something that's linear, of course, it's going to be a line, right? And so when we talk about linear stuff, we're going to be talking about a linear binomial. A linear binomial. So if we talk about a linear binomial, I guess we got to talk about how big its exponent is. What's the exponent going to be in a linear term? What's the biggest exponent going to be? Not infinity. In a quadratic, the biggest is 2. In a linear, the biggest is going to be. Is it going to be a 1? And this is varsity maths. Do we need to write the 1? No. So when we're talking about something linear, it's going to have an x to the first power in it. And a linear binomial, how many terms is a linear binomial going to have? 2. So it might have something like 18,357.52 plus 61x. That has 2 terms. Terms are separated by addition or subtraction. There's 2 terms. The biggest exponent that shows up is a 1. It's probably not written in the way we like it written. If we wrote that in the right form, it's kind of confusing. I better circle that. If we wrote that in the right form, we'd probably write 61x first plus 357.52. Right? That's in a form that we like it. So I'm going to be throwing these terms around regularly. Quadratic trinomial, linear binomial. Just so I wanted to make sure that everybody kind of understands, because if you don't understand the terminology, it's probably just going to go sailing right over your head. Okay? Cool. So the deal is then with this factoring, what we're really going to be doing, our goal, our objective in factoring is this. It's to rewrite a quadratic trinomial as the product of two linear binomials. That's what we're going to be doing. We're going to be rewriting a quadratic trinomial as the product of two linear binomials. That's what factoring in this context is all about. That's what factoring is. It's what it entails. We're essentially just going to rewrite something that has three terms. It's a quadratic. We're going to rewrite it as the product of two linear binomials. So to give you a more concrete example of that, we're going to have something like x squared plus bx plus c. And what we're going to do, our answer is going to be of this form. We're going to have an x here and an x here. And we don't know what the signs are going to be. For now, I'll just put pluses in, but those aren't always going to be pluses. And we're going to have some new number m here and some new number n here. It's kind of weird. But that's what we're going to be doing. We're going to go from three terms, the first one has an exponent of 2, down to a binomial and a binomial in parentheses. Remember when we foiled? We're basically unfoiling. We're going the opposite way. Everybody good so far? Awesome. I know some of you that already know how to factor. You're like, dude, come on, seriously? And if you've never learned to factor, this is your shot. This is your chance. So I have this one test in my archive that I like to give. It's a concept test. And one of the questions on it is this. Something tells us what M and N can be. Something tells us what numbers M and N can be. M and N, keep in mind, are going to be numbers. Okay? I should probably say something about that on the side. B, C, M, and N will be integers. Okay? B, C, M, and N will be integers. B, C, M, and N are going to be integers. And there's something that's going to tell us what M and N can be. Anybody know what it is? Using this model, using this, anybody know what tells us M and N could be? Here's a hint. It's either going to be X, or it's going to be B, or it's going to be C. X or B or C? C. C tells us what M and N can be. More specifically, C's factors. C's factors. What I'm trying to say here is that M and N will be factors of C. M and N are going to be factors of C. So on Monday, and again on Tuesday, and again today. I've said this before, I'll say it again. To be able to factor, you have to find factors of a number. To be able to factor, you have to find factors of a number. To be able to factor, you have to find factors of a number. To be able to factor, you're going to have to be able to find factors of that number C. So far, so good? Okay. Now, I like to follow this up with a stronger statement that says this. Something else tells us what M and N. What's a word stronger than can? Can's kind of vague. Can leaves it up in the air for debate. What's stronger than can? Will? One stronger than that. I like the M word. Might is a little vague. Stronger than might, but an M word that ends in T. Must. Must. What tells us what M and B must be? Somebody said it? Well, we said C tells us what they can be. Let's get B. B tells us what M and N must be. So the deal is M and N must have a sum. Now keep in mind these are integers, right? So integers can be positive or negative. They must have a sum equal to B. This is like factoring 101. This is like the heart and soul of factoring. This explains all of it. So when you try to factor something, you're going to be looking for factors of that constant term on the end that add up to equal the coefficient of that middle term. Ready to try an example? Let's try one. Example one. Example one, factor x to the squared minus 5x minus 6. Love this one. It's a great one. It's really good. So we know that our answer is going to have parenthesis, 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 right? And we know that in the parentheses, we're going to start off with an x and we're going to start off with an x. Now, there's a lot of teachers out there that when they teach this, they tell you all these sign rules. I'm not going to tell you the sign rules. I'll tell them, but I'm not going to write them down. If you go back and you reread these two statements and you think about these two statements and they make sense, you're going to be able to factor these all day. Piece of cake. When we factor, we got to look at that number on the end and find its factors. So we're going to be looking at that number on the end, 6, and in fact, it's actually negative 6. And we want to find its factors. Now, when you list out its factors, just for a minute, just forget about the negative for a minute. So 6's factors, 1 and 6, and 2 and 3, right? Okay. So we found the factors. Now keep in mind, it might be plus 1, plus 6. It might be minus 1, minus 6. It might be plus 2 and plus 3, or minus 2, minus 3. We don't know the signs yet, but we'll figure it out. B tells us what M and N must be. B tells us what M and N must be. So we want a pair of these. We want a pair of these that are going to add up to equal negative 5. So what are you thinking? 2 and 3? You might think 2 and 3. So you're going to plug in a 2 and you're going to plug in a 3. If you do that, what are the signs going to have to be? Negative and negative, right? So that's what you think. I'm going to rewrite these in blue this time. I'm going to write them lightly, though. You think it's negative 2 and you think it's negative 3, right? Negative 2 and negative 3. Well, the cool thing about foiling, factoring, you know which one it is? It's not those, is it? It's going to be negative 6 and 1. Here's the cool thing that I love about factoring. When you factor, if you are good at foiling, you can check your answer to see if you're right. Remember, this should end up foiling out to equal what we started with. This is x squared, no doubt about it. This is minus 2x. This is minus 3x. So this is x squared minus 5x. So far, we're looking like we're on the right track, right? But here's the deal. This last product, negative 2 times negative 3, what's that equal? That equals positive 6. But we want our answer, this has to be a negative 6. See that? So that sign on the end of that really tells us a couple things. That sign of that really kind of tells us a couple things. The fact that that last term has a negative on it, we know that the factors we use are going to have opposite signs. Okay? So if that's a negative, we're going to have opposite signs. We're going to have opposite signs. So that's something that may or may not help you moving forward. So the fact that that's a negative means we're going to have a plus and a minus. Now, if you would like to put the minus first and the plus later, I don't care which order you put them in. It really doesn't matter because of the commutative property. Minus plus or plus minus. What do we want first, the minus or the plus? Plus, okay. So 2 and 3 didn't work, so then we're going to have to try the other ones. And somebody said, what, minus 6? Minus 6 and plus on the 1. Will that get it done? Let's check it. Let's check it. X squared plus x minus 6x minus 6. That's x squared minus 5x minus 6. Bam. There it is. There it is. Cool beans. How do we feel about factoring? All right. That was a moderately difficult example because the 1 and the 6 could have worked and the 2 and the 3 also could have worked. But you really got to watch your signs. Signs are a big deal. Signs are a very big deal. Okay? You might want to make a note of that. Signs are a big deal. Signs are a big deal. A lot of people think, oh, it's just a minus sign or it's just a plus sign. No, that's a big deal. Signs are a very big deal. Exclamation point. Example 2. Factor x squared minus 5x plus 6. Yeah, that's just like the last one. Or is it? So we're looking at positive 6. We're looking at its factors. 1 and 6. 2 and 3. So the interesting thing here is, because this is positive, this means the signs are going to be the same. It means the signs are going to be the same in our answer. So we're either going to have plus and a plus, or maybe it's going to be a minus and a minus, but regardless, the signs are going to be the same. This one here tells us the signs are going to be what? Negative. The signs are going to have to be negative. So we're going to have a minus here and a minus here. So we got to figure out which pair of factors is going to add up or subtract to be 5. So what are we going to have to go with here? 2 and 3. So it's going to be x and a 2 and an x and a 3. And that's it. That's it. How do we feel about that one? Pretty good? Confident? Pretty macadocious? Example 3. Factor x to the squared minus 14x minus 72. You know, in every single class, there's always at least that one person that loves this for an answer. There's always that one person. You know what DNF means? In cross country, it means did not finish. But in factoring, you know what that means? Does not, did not, or does not factor. There's always somebody that wants to put that down because they think it doesn't factor. Sometimes they don't. But you can't declare that until you've tried every single possibility. So you got to find all the factors. So if you're that person that wants to be quick to say DNF, ask yourself, did I find all the factors of that number? So negative 72, we're going to find all its factors. Keep in mind our signs. What are our signs going to have to be here? Positive and negative, good. One's going to have to be positive, one's going to have to be negative. So the difference between these two numbers, these numbers when we subtract them in one way or the other are going to have to be 14 when we subtract them. Okay. So do 1 and 72, if we subtract them, is that going to equal 14? No, that's going to be 71, and that's not even close. What about 2 and 36? If we subtract those, we're going to get 34. That's not going to work. Dang it. What about 8 and 9? If we subtract those, what are we going to get? It's going to be 1, right? So 8 and 9 is not going to work. Oh, crap. 6 and 12. What if we subtract those? It's going to be 6. Is that going to work? Dang it. 7 plus 2 is 9. 9 is divisible by 3. This is 3 and... How many times does 3 go into 72? That's 2, that's 6, that's 1, that's 2, that's 3 and 24. 24 minus 3 is going to be 21. That's not going to work either. Dang it. Crap. So this doesn't work, this doesn't work, this doesn't work, this doesn't work, this doesn't work. So maybe it doesn't factor. Maybe we can put that stamp on it. What about 4 and 18? How'd you know 4 divides it? You found all the factors? Do you see why it's imperative to be able to find the factors of a number here? And you gotta find them all. A lot of people want to bust out this DNF stamp. You can't do that until you found all the factors. That's why we took 2 days out of class to talk about factors of a number, to talk about divisibility rules. So 4 goes into it half as many times as 36 did, so it's 4 and 18. Okay, so now I got to figure out which one's going to go where. I want 4 and 18 to add up to be negative 14. So which one's going to get the negative sign? 18. So 18 is going to go here. 4 is going to go here. And as they say, whoop, there it is. How do we feel about that? Pretty good? I want to try another one. Wouldn't be doing you any favors if I didn't do one like this. Example 4, factor negative x squared plus 5x minus 4. There's a few things in life that mathematicians really don't like. I know personally I don't like counting things. I'm awful at counting. Did I ever tell you about the one time I tried to count? My wife and I were arguing about how many flowers there were out front. I said I kept coming up short. She said, well, count them. I said, okay, 0, 1, 2. Anyway, mathematicians hate that. Leading negative out front. That's bad. We really don't like that. So what we want to do is we want to factor that out. Okay? We're going to factor out the negative. We're going to factor out the negative. Wow. That was weird. We're going to factor out the negative. Okay. Mathematicians having a leading negative term is like kryptonite. It's really bad. So when I factor that out, I'm going to have a negative sign out front, and what's going to happen is all 3 of those terms, their sign's just going to change. So the first term, instead of being negative x squared, is now going to be positive x squared. The middle term, instead of being plus 5x, it's going to be minus 5x. And the last term, instead of being minus 4, it's going to be plus 4. Everybody good with factoring out the negative? Okay, now that's the start of this, but we're not done. feel like one of those infomercial people. But wait, there's more. We're going to need to take this and see if we can't factor that. So maybe we can. Of course, we're going to have an x. We're going to have an x. What factors are we finding? The factors of 5 or the factors of 4? The factors of 4. So we're looking at 4, and it's positive 4. We're looking at the factors 1 and 4, and 2 and 2. It's going to be 1 and 4, okay. So it's going to be 1 and 4. What about our signs? What's going to happen there? They got to be the same, and they're both going to be negative, so a minus and a minus. Cool. Now, there's one more thing. When you factor out a negative, or a GCF for that matter, if you're factoring, it has to remain there. If you're factoring out something, when you're just factoring, it has to remain there. What I mean by that is this negative that we factored out, we have to show evidence that that's still a part of our answer. If we don't, then we've left out a part, and it's wrong. So we have to write the negative here, and this then is our final answer. Okay. So if you factor out a GCF, don't just throw it away. It still has to be a part of your answer, because when you factor, if I didn't say this, when you factor, if you FOIL out what you factored, it had better equal what you started with. And if it doesn't, then you factored wrong. I'll say that again. If you FOIL out what you factored, your answer had better end up equaling what you started with. And if it doesn't, then you factored the thing wrong. So let's FOIL that back out and see what happens. FOIL this back out. That's going to be x squared minus x minus 4x plus 4. That's x squared minus 5x plus 4, but there's a negative out front. So if we distribute a negative back in, we get minus x squared plus 5x minus 4, which is right back, which is right back where we started. If we didn't write that, if we didn't write this negative, it would be wrong. Everybody picking up what I'm putting down? Questions, comments, concerns, short debates, long debates. Last example, here it is. Example 5. Factor 5x squared minus 10x plus 5. There's more than one way to the Eastwood Mall. And we spent Monday talking about the factors of a number. We spent Tuesday talking about GCFs. There's a reason we talked about GCFs before we talked about factoring. If it's possible to factor a GCF out, you'd better do it first. If it's possible to factor out a GCF, you better do it first. So what I'm saying is factor out the GCF first. It's just going to make life so much easier on you later on. So we're going to factor out the GCF first. We're going to factor out the GCF first. First. Factor out the GCF first. What is the GCF? What is it? 5? Okay. So then the GCF is 5. So we're going to have 5 times some stuff. So each one of those 3 terms is getting divided by 5. So what's our first term in parentheses going to be? X squared, and then minus 2x, and then plus 1. Good. Oh, this is weird. Maybe this doesn't factor, because 1 doesn't have factors that add up to 2, does it? Scratching my head. 1's only factors are 1 and 1. What the heck? 5 times x and an x. What's going to happen here? It doesn't work? It does? What are we going to have to do? Minus 1 here, and then minus 1 again? Yeah. And this one's a special one that we'll be talking about on Friday. This is an okay answer. This is an okay answer, but it's not good enough. There is a better way to write this. Yeah. Yep. Oh, no. So if you had 5x minus 5, times x minus 1, I wouldn't be mad at you, but I would have to deduct a point because out of this, we can factor 5 out of that. So that would be 5 times x minus 1 times that other x minus 1. Right? But there is a one thing that we should be doing to this. When we have a quantity that's being multiplied by itself twice, how do we simplify that? Square it. So it should be 5 times x minus 1, the quantity squared. That's the best answer. That's the best answer. Okay. And we'll talk about that again on Friday. That's a very special case of factoring. So it's been real, it's been fun. I hope it's been educational. I hope that you could factor quadratic trinomials when our a value is 1. See you next time.
Good.